All right, so once again, you're welcome to Module 10 of our network defense. Our network defense training has 11 chapters or 11 modules, and we are the Module 10. And today's module is going to be brief. It doesn't have much. Tomorrow's module also is going to be brief. So let's dive into it. Network security data. Network security data. So basically, in this particular topic, we're going to be focusing on the types of security data and to describe the types of data used in security monitoring. Okay, we're also going to look at end device logs. That is your servers, your desktops, your operating systems, your IP cameras, all these end devices. We're going to be looking at their logs, okay? And describe the elements of that end device log. We're going to be looking at network logs. We're going to use different types of services to gather network logs, okay? There are certain software tools like TCP, DOM, Wireshark, Network Map. We're going to be looking at some of these tools that you can use to gather data for your own network security. So let's look at types of security data. Okay. All right. So here, come in. All right, here, alert data consists of messages generated by IPS, that's intrusion prevention systems, or IDS, intrusion detection system, in response to traffic and violation of rules, or matches the signature of a known exploit. A network intrusion detection system, such as SNOT, comes configured with rules from known exploits. Alerts are generated by SNOT and are made readable and searchable by SGIL and SQUAT applications, which are part of the security onion suite. Okay. So the essence of this topic is information you have fetched out from your devices. Okay, how this information are fetched out and how you can protect them. And so that's what we're looking at. So when we say intrusion IPS and IDS, they are actually applications or devices that helps us to generate certain information that can be of importance to us when it comes to security. So a testing site used to determine if SNOT is operating is a testmite site. It consists of single web page that displays only the user ID, which is 0, or the GID, group ID, all right, or the groups, okay? So it gives you that particular parameter. So if SNOT is operating correctly and the host visits this site, a signature will be matched and an alert will be triggered. This is an easy and harmless way to verify that the network intrusion detection system is running. So you use this SNOT application to work on it. So you may want to find out what is this SNOT that we are talking about. All right, because it is one of the tools that is helping us gather the data that we need. All right. Basically, the SNOT is, how do I put it? Is a real-time traffic analysis software. All right, it's an open source network intrusion detection prevention application. When we say open source, which means that It's open source. It's not, the codes are available for you to be able to play around with. Okay, so it's an IDS system which was later acquired by Cisco Systems. Okay, it is not to be confused with the term SNOT, but it is that application. And what it does is it helps you to do real-time traffic analysis. All right, it can analyze your traffic in real time, and helps you to detect suspicious activity. It can help you do packet logging. You can log in your packet where necessary. It has to do also with what they call rule-based detection and then things like that. So how it works particularly is like a packet sniffer. When we say packet sniffer, it's an application that helps you to sniff, to connect into the network and fetch out data. Okay, so it sniffs all incoming and outgoing packets that are passing through your network. So it alerts and documents those logs. So basically, that is not. So it's one of the applications that we use when you want to collect data, particularly. Okay, so session and transaction data. Session data is record of conversation between two network endpoints. Okay, the server could. Okay, I see Ruth has raised a hand. You have a question, Ruth Thomas?
Yes, sir. Good evening.
Good evening.
Yeah, I still want to relate this to this network analyzer you just spoke about.
Yes.
SNOT.
No, yes.
Can we relate it with things like this tool for monitoring network, SolarWinds,
Okay.
likes?
Okay. I think it's a very good question. SolarWinds, PRTG, all of them are powerful monitoring software. In fact, they are among the world-leading monitoring softwares. But the issue is that you need to pay humongously in order to get, because they are licensed, they are not open source. Okay, so
Yeah.
if you have the funding, then I will strongly recommend you go for SolarWinds. Even in the SolarWinds, it has different components. There's what they call the network traffic analyzer, the NTA. There's another one that is used for bandwidth monitoring. There's another one used for a topology layout. There's another one used for IPAM. There's another one used. So it has different components, all within the SolarWinds. So the SNOT here we're looking at is just a little aspect. And that aspect has to do with packet sniffing. Okay. It's like Wireshark. I don't know whether I think we talked about Wireshark in one of our
Yes.
So it is like Wireshark. Wireshark is a packet sniffing application. So you connect to the network and you're able to get a particular data. Okay. So basically that
That's
is
right.
Mm.
It's all right. Thank you, sir.
You are welcome. You're welcome. Okay. So the server could be inside the enterprise network or at a location accessed over the internet. So session data is data about the session. Remember when we talked about the OSI model and we were talking about one of the layers called the session layer. And that session layer is responsible for opening dialogues between the source and the destination and ensuring that there is free flow of communication between the source and destination. And if traffic is no longer passing through the channel, the session layer terminates that particular transaction. okay, it closes that particular port. So you may log into your firewall router or you log in your email and things like that. And if you leave it idle for a particular while, you see automatically the system times you out, or it tells you session timed out or something like that. So the session transaction data is to say that there is a way that it keeps record of when the session dialog is created, when it is open, the transaction that has happened while this particular dialog is open. Remember, today's topic is how we can generate this log and how we can secure it, the security data particularly. So as the data is passing through, there is a way you can actually document it. So session data is about the session, not that the data retrieved and used by the client. It's just about the session. So it will include identifying information such as the 5 tuples, of the source and destination IP addresses, the source and destination port numbers, and the IP code for the protocol that is being in use. All right, so data about the session typically includes what we call the session ID. So the amount of data transferred by source and destination and the information related during this session. Those are kind of the data that is being recorded. Because if you are doing a forensic data analytics, all right, or you are doing a forensic traffic audit of an event or a security breach, you are able to identify the time and the time frame that happened. Then if you have your session logs, you should be able to find out which session ID is used, what IP address is the source, what IP address is the destination. You'll be able to find out the port numbers that is being used. The port numbers that is being used tells you the application that is actually used in that. So data about the session typically includes like the session ID that we talked about, So the transaction data consists of text of the messages exchanged during the session, all right? Especially when you are doing your packet captures. So a session might include downloading of a content from a web server, like you can see here. This is the client. It makes a request to this server and then is currently downloading. So once it's downloading, the session keeps track of everything that has happened within that particular session. So the transaction that represents the request and replies would be logged in an access log of the server. You understand? So generally, when you're talking about session and transaction data, is focusing on from the time the dialogue is open for traffic to begin to flow to the point that dialogue is closed, all right, when the traffic ceases to flow. What actually happened? What are the data that is there? So that one is recorded. Another way to gather security data is what we call full packet capture, all right? So full packet capture actually are the most detailed network data that is generally collected and the most storage and retrieval intensive types of data used in the device. So they contain data about network conversations, and in the network conversations, we're talking about the session data between the source and the destination. So the actual content of the conversation, that's the text message of the email, the HTML web pages, and things like that. Now, why are we looking at this in comparison with the session data? The session data only keeps logs of what actually happens, okay? By time, so this IP address transmitted or sent a request to this destination. And this destination responded with the request of this. This transaction took so period and things like that. But here in the full packet capture, it is able to actually extract the content that is in the flow. You are able to intercept the traffic or the packet and interpret or inspect the content thereof. So the behavior that violates the business policy that is captured in that particular packet is extracted. All right. So as you can see in the figure, it illustrates the interface of the network analysis monitor component of the Cisco Prime infrastructure. All right. And a similar one is like the Wireshark that we know. So you will see that it will capture data and then it will interpret that particular data to be able to tell you this is the kind of thing that is going on. So let me see if I can launch my Wireshark and show you how when it does a full packet capture. Okay, let me share that. Share that. Okay, so this is like the Wireshark application, and as it is now, it's trying to tell me that there's traffic on my wireless. So if I just capture like this, you see, it's capturing the traffic currently flowing through my wireless, and most of the protocol is the ESP. All right, is the ESP protocol because I am live streaming and things like that. So we will find out what is going on very soon. But let me generate another traffic. Probably let me generate an ICMP traffic, but let me search ICMP here. Okay, let me search for ICMP here. So I'm searching for ICMP and I don't see anything here. So, but if I run a ping here, let me run a ping. Let me ping Google. Okay, so I'm running a ping on Google. All right, so if I'm running a ping on Google, for instance, then it should be able to capture my ICMP traffic that is going on. And we're going to see that very soon. If I open a web page, it should be able to capture that. So let me say I open, let's see, netacad.com. So I'm browsing through the web pages. So let me stop my capture now. So I've stopped my capture now. And with this, because I've stopped my full packet capture, I can search for protocols like, ICMP. If I'm searching for ICMP, I should be able to see my ICMP packets here. If I do ESP, this is my ESP packets. So if I select one, for instance, I come down here, it's going to give me the details. This is the UDP. This is the source port. Okay. This is the destination port. This is like my layer 4. Okay. Internet protocol is my layer 3. Okay. In my layer 3, I'll be looking at source IP address and destination IP address. Look at it here. Source IP and destination IP. This one here is my layer 2. Ethernet 2 is my layer 2. And in layer 2, I'll be focusing on source MAC address and destination MAC address. And look at it. This is the destination MAC address. This is the source MAC address. Okay. And then here is going to be my layer 1. My layer 1 is concerned about how the traffic is encoded into my network media. And the network media I'm using is wireless. All right. And that is why it's is giving me this particular encoding. Okay. So if I go down here, this is my encapsulation details coming. So you see, generally, this is the information. And if I want to begin to decrypt this information, I can go on and on and on. Let me see. I'm supposed to see ICMP. Okay, probably I didn't capture the ICMP very well. So Let me see if I can continue without saving. All right, so let me see which coming. Okay. Okay. So, okay, probably I'm not generating, but I'm generating my ICMP. So I will find out why my ICMP is not, maybe I'm not capturing it properly, but it's supposed to capture the protocol here or HTTP protocol here. So I will check that maybe before the end of the class, and then we'll see about that. So generally, like I said, this is, okay, you can see. All right, so basically this is it. I'm just trying to see if I can see other protocols that are here. Right? Anyway, so most of the other applications are like this. That is why you can see it like that. Statistical data. Statistical data is about network traffic and created through the analysis of other forms of the network data. So statistical characteristics of normal network behavior can be compared to current network traffic, to detect anomalies. So statistics can be used to characterize normal amount of variation in network traffic patterns to identify network conditions that are significantly outside those ranges. So statistically, significant difference should raise alarms and prompt injection. What are we talking about? When you say statistical data, it basically has to do with history and comparison, which means it will collect this data for a particular period, and then it will begin to analyze and do some comparisons, okay? And comparisons and group classification, comparisons and grouping of this particular data. And then it will now bring a particular statistics to you to tell you that, okay, we have this number of intrusion fail attempts, all right? And it is coming from this source. We have more of the attempts on email, or we have this on this. So it will now give you some statistics that will help you. So network behavior analysis, NBA, and the network behavior anomaly detection are approaches to network security monitoring that use advanced analytical techniques to analyze net flow and internet protocol information export. All right. So techniques such as predictive analytical artificial intelligence perform advanced analysis of detailed session of data. Okay. So end device logs. End device logs. So host-based intrusion detection systems can detect and prevent intrusion. So it creates logs and stores them on the host. And many host-based protection have a way to submit logs to centralized log management servers. HDIS, which is host-based intrusion detection system, can use agents to submit logs to management servers, and the logs can be searched from central locations using the NSM tools. All right, so Microsoft Windows hosts are visibly local, through Event Viewer, which helps to keep 5 types of logs. It keeps the application log, system log, setup log, and things like that. So how do you get it? It's very simple. It comes in both CLI and GUI. So if I go to Event Viewer, okay, let me share it so that you can see. Okay, where are you? Events. Okay. So this is like the event viewer for the system. So you have custom logs with Windows logs, application and services logs, and then what do they call it? Subscriptions. All right. So you see, this is like the summary of the administrative events. The number of errors, the number of warnings, the number of information, the number of audit successes, and things like that. So if I want to go into details, these are like summary of each one of it. If you want to go into detail, you can come here. Let's say Windows log. Under Windows log, there is application, security, setup, and system. So if I go to security, for instance, then I want to look at what are the security issues. So these are the security audits that I have gotten. So for this first one, is credential manager was read. You know, in order to check the credential of my system to ensure that everything of my system is licensed and is okay. That is what is happening here. So it says this event occurs when a user performs a read operation on stored credentials on in Credentials Manager, and everything here is success. All right. So I can go to application, for instance. All the applications that I have, like this first information, it says successfully scheduled software protection services for a restart on these days. All right. Now, there is a warning it has given me here. It says this rule engine reported a failed virtual level activation attempt. All right. And then it's giving me, so I can pick this particular code and Google it and see what this particular error is. And I can go down here. There's another one. There's another error here. And it's giving me the description of the event. So you see, these are all logs and details that are there for me. If I go to system, the same thing I will get. If I come to application and services, I will have hardware events. Here, I will have Internet Explorer events. If there's any, I will have there. If I have Open SSH, if there are SSH, I get it there. Subscriptions, if I come down here, anyway, let me just go. So generally, that is what happens when you come to the events. So this is like the administrative one. Number of events here, there are about 31,000 plus. And then I have an error here. You have to study it. So most of the times, our systems tend to have these particular events, including the host event. So like we said, we have the error, the warning, the information, the success. So what does it mean if you see an error? It is an event that indicates a significant problem, such as loss of data or loss of functionality. Okay, when you see a warning, it is an event that is not necessarily significant, but may indicate a possible problem. So if an application can recover from an event without loss of functionality or data. When you see information, it just describes the successful operation of an application, a driver or a service and things like that. When you see success audit, like the one I showed you, it is an event that records an audited security access attempt that is successful. If you see failure audit, it tells you there is an event that record an audited security access attempt that fails. How about syslog? Remember, we're looking at end devices now in the log. Syslog is just system logs. All right, so it includes specifications for message formats, a client-server application structure, and a network protocol. So syslog is like, I'm building a particular server so that every device on my network, whether intermediary or host device, will drop or store their logs over there. Okay, so usually it has like a structure in which it stores the message. It has the PRI talking about priority, all right, which means any information there is high, it has high value priority. So you see PRI. When you see the header here, it's talking about the timestamp. It will give you the timestamp of the message, all right? the day, the month, the hour, the minute, the seconds, and things like that. And then the MSG here is like the message that comes with it, all right, in the syslog. So when you see syslog errors or information, it has what they call emergency, it has alert, it has critical, error, warning, notice, information, and debug. All right, so it has all this. Where we all right. So it has all this. That is the syslog. Okay. So, but you need to be able to understand what each one of this is. Emergency means system is unusable and it requires an emergency salvage. Alert means that an action must be taken immediately. And when you see critical, it's a condition that should be corrected immediately and indicates a failure in the system. When you see error, it's a failure that is not urgent, but could be resolved within a given time. When you see warning, an error does not presently exist. However, an error will occur in the future if the condition is not addressed. Okay, so basically, these are like information flows that it shows there. The server logs are essential sources of data for network security monitoring. Network application servers such as email and web servers keep across the error logs. DNS proxy server logs, which document all the DNS queries and responses that occur in the network, are especially important. So DNS proxy logs are useful for identifying hosts that may have visited dangerous websites, for identifying DNS and exfiltration and connection to malware command and control servers. All right. These are general terms and technological terms that we come across very often when we are dealing with network administration. But for those of you, in case that you are still having difficulty understanding it, like I said, there is a network basic course that I am taking. So I'm still sending it on the YouTube link so that you may have to follow it through so that you can understand some of these terminologies. But if you understand this, you will understand that what we are talking about here is the essence of logs. And where we are talking about these logs is for forensic investigation, is for audit, and is for troubleshooting. Okay, so server logs have to do with logs on your servers, particularly maybe your Unix or your Linux servers or whatever machine that you're using to host your services. All right, so others may use proprietary logging. The constant content of the log files event upload on the type, depend on the type of the server. So that is very, very important for you to know. Then there's another device that does log collection, the CM. Okay, the CM stands for Security Information and Event Management. Security Information and Event Management Technology. So it's used in many organizations to provide real-time reporting and long-time analysis of security events. So it combines the essential functions of network security events management and the security information management as well to provide a comprehensive view of the enterprise network using the functions. Okay, so it's like one device that will collect the different data from the different points, components, and then bring it in a summarized form for you, and then analyze and make certain recommendations for you. Okay, it may look at all this and say, there are multiple threat events occurring on this particular application. You may need to change your password, or you may need to tighten up your security, or you may need to look at this loophole. So it goes to the extent of even giving you that. So some of the functions that it does in the CM, it does what we call log collection. So it collects the event logs from different sources in your organization. It also does normalization, which maps all these log messages from different systems into common data model. So when we say different systems, we're talking about other servers, cameras, routers, switches, devices, firewalls. So it collects all the logs from all these devices and then process them together. So it also does a correlation. It means it links logs and events from disparate systems or applications. And then it does aggregation, all right, which reduces the volume of event data by consolidating duplicates and event records. It also does reporting and presents the correlated aggregated event data in real-time monitoring and long-time summaries, including a graphical interactive dashboard. So it shows you the fact that, we have this number of attacks, or we have a possible attack on this, or we have a vulnerability here that we need to work on. Okay, so the CM actually does a lot of this particular service because it collects this information. All right. Now, let's look at the network logs. I've looked at the host log. The network logs, these are some tools or applications that I would recommend you to look at, download it and practice it, and then see how it can help you manage your own network. The first one is what we call the TCP dump. Okay. The first one is called the TCP dump. And you may, the TCP dump is an interesting application, you know, and what does it do? It also does like the packet capturing. Okay, you know, like the packet, it's like a sniffer also, you know, it captures packets on the network interfaces with respect to time, and it does filtering and uses powerful filtering expressions to capture only traffic you are interested in. It also does some data analytics and even does offline whatever they use. So it's like a packet analyzer or a traffic analyzer that you can use. And like we said, it's an interesting tool that you can have it both on GUI and you can also have it on, what do they call it, on command line interface. Another application that if you find time, install it and practice it, you will see how it will help you on your network, is the net flow. The net flow is just towards network flow or network traffic flow. All right, so it views your network traffic flow and gives you results in graphical usage. So it's a protocol developed by Cisco as a tool for network troubleshooting and session-based accounting. So it effectively provides an important set of services for IP applications. So it provides valuable information about network users, application, peak usage time, and traffic routing. So it does not do full packet capture or captures the actual content like we see in the packet, what do they call it? A packet sniffer, Wireshark or something like that. So it records information about the flow, including the metadata, you know. So NetFlow is a very, very good tool. And the information, it helps you to manage, capture like the source IP address, destination, the source port and destination, the protocol layer 3, whether it's IP version 4 or IP version 6, the class of service, and tells you the router or the switch interface that you are being used. So that device is very, 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 very good. Then we have the application visibility and control. Okay, this is another device that basically combines multiple technologies together, you know, and recognize, it will analyze, it will control, it will manage your voice, video, filtering, email, file sharing, gaming, point-to-point, cloud-based. It's like what we call the all-in-one. It's like what they call all-in-one. So it's one device that has all these things combined in together. So that's why they call it the application visibility control. So a management and reporting system such as Cisco Prime analyzes and presents the application analysis data into dashboard reports for use by personnel. So content filter logs, device that provides content filtering such as Cisco ESA and the Cisco WSA provides a wide range of functionalities for security monitoring. All right. Another tool I forgot to include here, which maybe we'll talk about another time, is what they call the Zabbix. The Zabbix, if you are a network administrator, like Ruth that was talking about SolarWinds. Okay, SolarWinds is powerful, is good. PRTG is another powerful tool. But if you don't have money to purchase those, you can try one called Zabbix. Zabbix is a very, very, very powerful tool, and yet it's completely free. So it does almost, if not all, the things that the other ones does, and then it's completely free. So it does traffic management, traffic monitoring, and it also does device what do they call it? Now, it monitors your device, monitors your bandwidth, monitors the lifeline of your device for your servers, it keeps track of your storage and things like that. So all these applications that we are talking about, they are very, very, very important, and they are the tools that you as a network administrator need, because you cannot call yourself a network administrator and if you don't have tools that will give you the necessary information about your network, about how your network is doing and how you are managing it and things like that, right? So proxy logs. Proxy servers are devices that act as intermediaries for network clients that contain variable logs that are a primary source of data for network security monitoring. So an enterprise may configure a web proxy to handle web applications on the behalf of clients instead of requests for web resources being sent directly to the server from the client. The request is sent to the proxy server first. The proxy server requests the resources and returns them to the client and generate logs of all the requests and responses. So the logs are analyzed to determine which hosts are making the request, whether the destination are safe or potentially malicious, and also gain insights into kind of resources that have been downloaded. So web proxies provides data that helps determine whether responses from the web were generated in response to legitimate requests or have been manipulated to appear to be responsible, but are in fact exploits. So, like we said, proxy is when you don't go direct. You are using another device before you get into the destination. So proxy logs is when you are having another device before you get to the main destination. Then we have what we call the next generation firewalls. The next generation firewalls, very interesting device, all right? Because they extend the network security beyond just IP address and beyond just the layer 3 and layer 4 that we all know, all right? It goes to the topmost layer. So one of those functionality is a reporting dashboard with interactive features that allow pick point and click reports on very specific information without the need for a CM or the event correlators. Okay, so if you have this, you don't need most of those other devices because they come into it. So Cisco's inline next generation firewall device uses firepower services to consolidate multiple security layers into a single platform containing cost and flying. So you see, Cisco has the next generation firewall. Almost all other companies have it also. Fortinet have it, Sophos have it, Sonic Wall have it. Most of these companies, security companies, are beginning to have it. And they all have it because it carries a similar procedure, event. What are those events? Include connection event, intrusion event, host or endpoint event, network discovery event, network flow event, intrusion and detection, and then intrusion and prevention. So it carries all of them together. So this is the summary for this is the end for module 10. And like we said, module 10, we looked at network security data. All right. So the data that you are using in network security, how it will help you to secure your network, how it could either make your network vulnerable or make your network very, very useful. So this is where we'll draw the curtain for today's class, except maybe anyone has a question you want to ask or contribution to make. This is it. So do we have any question or contribution?
Okay, yeah, maybe a question.
All right, go ahead.
Yeah, I discovered that, okay, in all of this that we've been discussing, we are dwelling more of the physical networks, or maybe we're looking at the physical networks enablement. But when you look at, when you're actually looking at the cloud, the cloud network, what are the devices that you use? Because maybe I can only just relate maybe the proxy and maybe the next generation firewall. So which other ones do you think are also very useful when you look at when you're looking at the cloud infrastructure this time around, or network on the cloud?
Okay, very, very powerful question. Very interesting. Now, we looked at the cloud infrastructure in our previous class. So let's take a little review. When we say the cloud network or the cloud infrastructure, what are we talking about? Basically, it is a physical server room like this. It's a physical server room that has racks, and racks in it. Inside the racks, you have the network rack, you have the server racks. The network racks are the rack that carries your network devices, carries your routers, carries your switches, carries your firewall, carries your, all those devices. Your server racks are the racks that carries your servers, all right? Carries your storage servers, carries your, what do they call it now? Your virtual machines, your VM servers, carries your, all the server based. Now, and then you have the rack that controls the connection of all these things. Now, part of these services that is offered in this particular server room is what they call the cloud service. Why is it called the cloud service? Because you are providing the services to somebody that is remote. Somebody is somewhere and says, okay, I don't want to build a server room. I don't want to build an infrastructure. I don't have the capacity. So what do I need? What I need is that I am going to purchase, I want to ask you to lease some of this to me. And what are those things? I give you what they call infrastructure as a service, all right? Or it gives you platform as a service, all right? Or it gives you software as a service. Now, when he is giving you infrastructure as a service, it is saying that, okay, this particular PC here is leasing a particular virtual machine that is located on the rack in a particular server managed by a particular network that has all the devices required. So you, the client, do not need to know, you don't need to worry yourself about what is sitting in the server room over there. And so you get provided with the service that you need, maybe a server with this 2 terabyte of storage, maybe 8 gig of RAM, this and this and this infrastructure, this size of bandwidth, this and this and this and this. Or you want to say platform as a service. So you see, in the infrastructure, you are the one to install the operating system. You are the one to install the platform. You are the one to install the application. You are the one to manage everything. But in platform as a service, you see the person managing the server room. The person managing the server room or the cloud facility over there is like your programmer. So he owns the infrastructure. He now installs the platform for you to now do your programming. So the platform enables you, the person requesting for the service to say, okay, I'll program and install my program on it. So you create your own platform. And then the software as a service is where the owner of the facility has built his own softwares, and then he's leasing the softwares for you. For instance, you're using Gmail or OneDrive, or Microsoft 365, or, all those ones are applications, and we're just using them, we're paying for them, and you're using them as a service. So if you want to look at network security in that aspect, you need to now, don't look at it from the side of the client. You need to come and look at it from the side of the owner of the server room. Okay, the owner of the server room, what devices are located there? How are the devices connected? Is it secure enough for this user, this remote user that is trying to purchase this service? Is it secure or is it not secure? So you look at it like a physical device, okay? But if you want to look at it from the side of the client, then you need to look at it, what type of service is the client requesting? Is it infrastructure as a service? Then the kind of security policies you're going to be looking at for that particular person is much more detailed than platform as a service and also than software as a service. Okay, so I don't know whether that has answered your question. If it has not, let me know so that I can throw more light in the area that I have not. So has it answered the question?
Yeah, I think basically, yeah, it does, because it means, well, since we're actually connected to the cloud platform, it means that we don't need to worry so much what's happening in the cloud data center, because they manage their stuff. And so yeah, so because the effect of maybe the network in the network engineer, it's actually maybe those ones will be at the level of the data centers and the rest. I think it's okay. It does.
All right. Thank you very, very, very much for your question. All right. Yeah. Any other?
There may be just a quick one. I don't know. Yes. Your Epic pen now, is it this is outside this anyway? Okay. The pen you're using now, is it Windows enabled or you installed it?
It's just Windows enabled. Just on your PowerPoint, you can get that.
Okay.
Yes.
Okay.
So all you just need to do is just right click and come there to see PowerPoint options. I don't know whether you can see that. Then you select the laser or the highlighter or whatever. So if I pick the highlighter, I can come and highlight something like this, so if I pick a laser, so you see it's just pointing the laser and things like that. So it's just with the application.
Okay, it's all right. Okay, yeah, thanks.
All right. Very, very happy to have you guys. Tomorrow we will be rounding up. Okay. So we're supposed to have the class by 6, but I think we should still have the class by 8 o'clock tomorrow. Okay, so I'll plead for us to maintain the 8 o'clock period so that we can just use the opportunity to tidy up anything that is remaining. We'll see you guys tomorrow, and good luck.
Thank you very much, sir.
Welcome.